Welcome to Quantum Tech Sage. In this video, we are building a real working app using Claude and MCP, the Model Context Protocol. No fluff, no abstract diagrams that go nowhere. By the end, you will have a local MCP server running, tools defined and wired up, and Claude making actual calls through them. This is a hands-on walkthrough, so follow along. The full code is in the description. Here's the core problem MCP solves. Right now, Claude is incredibly capable, but it's trapped in the chat window. You want it to read a file. You paste it. You want it to check your project structure. You paste that too. It's one-directional and it doesn't scale. MCP changes this. It gives Claude a set of tools it can call directly. Your tools, running locally, returning real data. Claude goes from being a smart assistant, you copy-paste, to and from, to being an active participant in your actual environment. MCP stands for Model Context Protocol, and the name is less intimidating than it sounds. The simplest mental model, it's a standard plug socket between Claude and the outside world. You build a small server that exposes tools, read a file, search a database, call an API, and Claude can call those tools mid-conversation whenever it needs them. It decides when to call a tool, passes the right arguments, gets the result back, and uses it. You don't manage the plumbing. You just define what the tool does. Here's how all the pieces connect. On the far left, you write the MCP server and define its tools. That's literally just a small node or Python file. Your MCP server runs locally on your machine and exposes those tools over a standard protocol using JSON-RPC calls. Claude's API sits in the middle. It receives your message, decides which tool to call, fires the call to your server, gets the result back, and incorporates that into its response. And on the right, your app receives Claude's final structured output and displays it to the user. The key insight: the only piece you write is the MCP server with your tools. Everything else is handled by the protocol and the Claude API. Here's what we're building: a smart notes assistant. Claude will be able to read, search, and create markdown notes in a local folder on your machine. We'll build 3 MCP tools. First, list_notes. Claude calls this to see what files exist in your notes folder. Second, read_note. Claude calls this to pull the full content of a specific note. Third, create_note. Claude calls this to write a brand new markdown note with a title and content you specify in the conversation. 3 tools. That's the whole app. Let's build it. Right. Let's get set up. You need node 18 or higher. Open your terminal and create a new folder called notes-assistant, then run npm init to initialize the project. Install 2 packages, the Anthropic SDK for talking to Claude, and the MCP SDK, which gives you the server scaffolding. Create a notes folder. This is where your markdown files will live. Drop 1 test file in there, so we have something to read. Your final structure is simple: a server.js file that runs the MCP server, a client.js file that talks to Claude, and the notes folder. That's it. Here's the server skeleton. This goes in server.js. We import the server class and the stdio server transport from the MCP SDK, plus nodes built-in FS and path modules. We set a notes_dir constant pointing to our notes folder. Then we create a new server instance, give it a name and version, and tell it we'll be exposing tools. The main function connects the server to a stdio transport. That means Claude talks to your server over standard input and output. So no HTTP server, no port, no network config required. The comment in the middle is where our 3 tools go. We'll fill that in right now. Here are all 3 tools. Each one follows the same pattern. Server.tool, a name string, an optional schema for the parameters, and an async handler function. List_notes takes no parameters. It reads the notes directory, filters for markdown files, and returns the list as plain text. Read_note takes a file name string. It reads that file's full content and returns it. Create_note takes a title and content. It sanitizes the title into a file name. Lowercase. Spaces replaced with hyphens. .md appended. Writes the file and returns the file name it created. Notice the return format. Always an object with a content array, each item having a type and text. That's the MCP response contract. Claude knows how to read this. Now the client file. Client.js. This is what you actually run. Step 1. It starts your MCP server as a child process using stdio client transport. You just give it the command node and the file name server.js. The client manages the subprocess for you. Step 2. It calls list tools on the MCP client to discover what tools your server exposes, then converts them into the format Anthropic's API expects. This is the bridge between the two protocols. Step 3. It creates an Anthropic client and sends a message. Summarize all my notes. With the tools list attached. Claude reads the available tools, decides to call list_notes to see what exists, then calls read_note for each one, and finally sends back a summary. All of that tool calling loop happens automatically. You write the tools. Claude decides when and how to use them. Time to run it. One command, nodeclient.js. That's it. The client starts your MCP server automatically as a subprocess. What you'll see happen, Claude calls list_notes first to discover what files exist. Then it calls read_note for each file it wants to read. Then it synthesizes everything into a natural language summary and returns it. You can change the message to anything. Create a note. Find something specific. Reorganize content. Claude decides which tools to call in what order. This is the power of MCP. You defined 3 functions, and Claude turned them into a working AI assistant that knows your notes. Let's demystify what's actually happening when Claude uses your tools. Step 1. Your prompt arrives. Claude receives your message along with the list of available tools. Step 2. Claude decides which tool to call first based on the task. It generates a structured tool use block, not a text response. Step 3. Your MCP server receives that tool call, executes the actual function, reading a file, querying a database, whatever, and returns the result. Step 4. The result goes back to Claude, which reads it and decides whether it needs to call another tool or whether it has enough to answer. This loop repeats as many times as needed. Then step 5. Claude synthesizes everything it learned from all the tool calls and writes your final answer. You don't manage this loop. The MCP protocol and the Anthropic SDK handle it automatically. The 3 tools you built today are just one configuration of this pattern. The MCP server structure is completely reusable. Want a GitHub issues bot? Replace the file tools with GitHub API calls. List issues, add comments, close issues, and Claude triages your repo. Want a codebase explorer? Tools that walk a directory and read source files give Claude a live view of any project, no matter how large. A secrets manager? A meeting summarizer? Same pattern, different tool implementations. The key insight: MCP separates the capability definition from the AI reasoning. You own the capability layer. Claude owns the reasoning layer. That separation is what makes this pattern so composable. Quick reference before you go. The MCP tool pattern is literally 3 lines. Register the tool name, define the parameter schema, implement the handler, return the content object. That's the whole contract. 3 rules worth remembering. 1. Always return the MCP content format. Claude expects that exact shape. If you return anything else, it won't work. 2. Keep tools single purpose. Don't try to build a mega tool that does 5 things. Define 5 small tools and let Claude chain them. 3. Handle errors inside the handler. Return a descriptive error message as text rather than throwing. Claude will read the error and adjust. Often it'll try a different approach automatically. That's the full walkthrough. You set up an MCP server from scratch, defined 3 real tools, wired Claude into them through the client, and watched the agentic loop run live. The full code is linked in the description. Clone it, run it, then start swapping the tool implementations for whatever you actually want Claude to do. If this was useful, then like, share, and subscribe Quantum Tech Sage.